Dear students, I am Sandra, working as a physics faculty in Target English Medium School. Today, in this part video, from the chapter of Refraction of Light at Plane Surfaces, I would like to teach what is the real depth, apparent depth and apparent shift. These topics we discussed in this part video from the chapter of Refraction of Light at Plane Surfaces. This is the name of the topic: real depth, apparent depth and apparent shift. So listen. First, I will tell the definition. After that, I will explain with help of a diagram neatly. What is the real depth means? The actual distance between the original or initial position of the object to the refracting surface beneath the refracting surface is called real depth. Listen very carefully. The actual distance between the original or initial position of the object beneath the surface to the refracting surface is called real depth. Apparent depth is nothing but the distance between the refracting surface to the virtual image is called apparent depth. Apparent shift or raised position or vertical shift, listen very carefully, it is we can call in different names: apparent shift or vertical shift or raised position based on the concepts. That's why apparent shift we are also called as vertical shift or raised position is nothing but the vertical distance between the original or initial position of the body to the virtual image is called apparent shift or vertical shift or raised position. So now I will explain with help of a diagram. So which is the real depth, which is the apparent, and what is the apparent shift, that is we discussed. So here we observe this diagram very carefully. First of all, we place an object at the bottom of the beaker. So initially where the object will be placed at the bottom of the beaker, that is we can say as initial or original position of the object. Now the beaker is filled with water up to certain level. So this surface of the water we are called as refracting surface. We know that because of from this surface will be separate the rarer medium and denser medium. So beneath this surface, this totally water is there. This is the denser medium. Above this one, air is there. That is the what is the rarer medium. Now observer is in which medium? Rarer medium, and the object is where? In the denser medium. Because the object is placed in a beaker, the beaker is already filled with water. That's why object is in the denser medium and observer is in the rarer medium. Now here the observer was seeing the which one? Object. But the object was not appeared to here, the object is appeared to here. How means I say that? So from the initial position of the object, for understanding of this one, I will explain. Okay. Now up to here, the water will be filled. Like this is S dash. S dash is the surface of the water in the beaker. Now here, in this place, what you placed? A coin or any object is placed. That is the O. O is the position of the object. Now from this object, okay, the rays are emitted. So one ray is travel normally for the refracting surface. We know that when the light is travel normal to the refracting surface, it is undeviated after the refraction. That's why OAN is means OA is the one incident ray and another ray will be fall onto the S dash with obliquely, not parallel to that one. That's why at this point we draw a normal, that is the N, here M. NM is parallel to the ON, or NBM is parallel to the NAO, that is we know that. At this point we know that light is travel from where to where? Denser to rarer. That's why when light travel from denser to rarer, the light is not okay, the light is deviated from its path and move away from the normal. That's why, so this is one. Here observer eye we can consider that like this one. But here the coin was seen by which one? Observer. That's why you consider that observer is in the rarer medium and coin is in the denser medium. But the coin is not appeared here. When initially, when we can before pour the water in the beaker, the coin is appeared here only when you can see from this one. But after fill the water, the same beaker, the coin is not appeared here. It is appeared to very near to our eye. It is nothing but the coin position is displaced. But really it is displaced? No, it is the imaginary, means it is the illusion. So but where the coin is appeared means the refracted ray. So here, how many refracted rays are there? You know that where the image, when the image will be formed after the reflection or refraction, either the rays are really meet or appears to meet the light. Okay, at that point, what will be formed? Image will be formed. Here, how many rays we can say? The two rays. This is the first ray. It is the second ray. The first ray will be fall normally to the surface and second one will be fall obliquely to the surface. Anyone? So this is the first refracted ray, it is the second refracted ray. The first refracted ray produced backward and second refracted is also produced backward. Where these two rays are meet at that point, what will be formed? Image will be formed. This image is virtual image or real image? It is the virtual image. Why? So we know that if rays are really meet, which image will be formed? Real image. If rays are appears to meet, which image will be formed? Virtual image. Here, after the refraction, this is the first refracted ray, it is the second one. These two are in different direction. They never meet after the refraction in the rarer medium. That's why, but these two rays are produced backward. At this point, they are appears to meet. That's why at this point, which image will be formed? Virtual image will be formed. Now we are observing from the view of which position? Observer. Means observer is in the rarer, object is in the denser. That's why for this point, it is the angle I from the view of observer. Next, it is called angle R because of it is the normal, it is the refracted ray. So it is the incident ray, it is the normal. The angle between the incident ray and normal is called angle I. That is, you know that. And okay, it is the angle R because of now here we are observing like this one. This part. In this part, this is which one? Diagonal. For this diagonal, so it is the angle R means it is also angle R. Opposite angles are equal. So the rectangle. So we are observing that like this one. So it is the here angle R means what is this one? It is also angle R. Opposite angles are equal. So that's why I will draw in this diagram. So it is the angle I in the view of observer. It is I, it is I, it is R, it is the R. We can say that. So it is the real position of the object. It is the virtual image. This is the refracting surface. Here, according to the statement of real depth, apparent depth and apparent shift, which is I says that the actual distance from initial position of the object to refracting surface means here to here. So here to here, this distance is called real depth. The distance, the actual distance from the initial or original position of the object to refracting surface, this is called here to here is called real depth. Means really the object is at this position from the refracting surface of the water or beneath the surface of the water. Next one, apparent depth is nothing but the distance between refracting surface to virtual image. Here virtual image will be formed. That's why this distance we are called which one? This distance is called apparent depth. Then what about the apparent shift? Apparent shift means I say that the vertical distance between initial position of a body to virtual image means this one we call apparent shift. So listen. So real depth means the distance between the initial position of a body to refracting surface is called, this is the real depth. The distance from real refracting surface to virtual image is called apparent depth, and the distance between initial position of the object to virtual image, this is called apparent shift or vertical shift or raised position. Means the position of a body will be upward to rise from O to I. So what is the formula to find means how much distance or what is the vertical shift, how we can find mathematically, or how much height the body will be raised after fill the water. That is we discuss how we can find in this one. So from the diagram we are observing that NAO, MBO dash, these two are parallel each other. Now here okay, AIB from the triangle AIB and side I is equals to. So what we can write from triangle AIB sine I is equals to, what we can write, sine I is nothing but opposite side by hypotenuse. That's why we can write AB upon BI. Is it correct or not? AB upon BI. Next one, triangle like the same way. A O B. It is also a right angle triangle. That's why A O B. Here angle is there. This is the side R. Sine R is equals to opposite side by hypotenuse is nothing but AB upon BO. If OB incident ray. If OB incident ray is very nearer to the point A, or if B is very nearer to the, simple like this one also we can write. If B point is very nearer to the point A. So means here, what is the meaning of that one? The angle of, okay, so R is very small. Means for the small angle of incident, angle of refraction is also small. We know that. Okay, so means here the light is travel from radar to denser. When light is travel from radar to denser, in the view of observer, angle I is greater than the angle R. That's why if angle I is small, angle R is also small. We know that. Okay, angle I is 10, then what is the angle R? 6.5. If angle I is 5, then what about this one? Okay, half of the 6.5. So it's nothing but 3.25. If angle I is 3, then what is this one? Very small. That's why, so means angle of incident is very small, then what will be happen? Okay, so the point B is very near to the point A. Is it correct or not? Because of his refracted angle is very small. So that's why if point B is very near to the point A, so that's why this point is very near to the point this one. Is nothing but simply for this diagram. It is the O, A, N. If this one, like this, so it is the point B, it is the M, it is the O dash. That's why if point B is very near to the point A, or whatever the angles we can leave laterally, if point B is very near to the point A, then what will be happen? AO is equals to BO, because of, okay, these two are very near. Very near means like very near. So below the 0.5 centimeter, then almost when you are observing that A and B are coincide and appears as the same point. That's why if point B is very nearer to the point A, below the 0.5 centimeter distance between them, at that time when you can see from outside the point A and point B are intersecting, or appears to, are due to the superposition, that appears as a single point. That's why AO is equals to BO, or BO is equals to, what is that one? AO, because of A is equals to B. So that's why if point B is very near to the point A, then what we can write? A and B are superposition. That's why BO is BAO and BI is also AI. So that's why what we can write? Sine. So means here what we can write? BO is equals to AO and BI is equals to AI. When this condition is possible, so the point B is very nearer to the point A. At that time, this situation is possible. Because of, we know that from this point, number of rays are emitted. Some rays are fall very near to this one. Some rays are fall from this one. Far from this one. That's why the ray which is considered near to the point A, at that time BO is equals to AO and BI is equals to AI. These values are substituted here. Then sine I is equals to AB upon AI and sine R is equals to AB upon AO. So what is the sine I value? Sine I is equals to AB upon AI and sin R is equals to AB upon AO. This values you can get previously. Now, according to the Snell's law of refraction, according to the Snell's law, because of here light is the travel from rarer to denser or denser to rarer. So in the view of observer from rarer to denser, that's why we know that according to the relative refractive index concept, or leave it according to the Snell's law of refraction. Because of why we consider the Snell's law of refraction means the Snell's law of refraction, we know that the ratio of sine of angle of incident to the sine of angle of refraction is always constant for a given pair of media. Here, which is the pair of media? Air and water. That's why at the same time in the Snell's law we want sin I and sin R. Already sin I is there and sin R is also we find from the diagram. That's why according to the Snell's law, simply mu is equals to sin I upon sin R, or sin I by sin R is equals to mu or constant or n also, anyone you can say that. Then mu is equals to sin I means what is that one? AB upon AI. AB upon AI by AB upon AO. It is brings to the numerator side. Then mu is equals to AB upon AI into. So it is brings to the numerator side. These two are reciprocal. AO upon AB. AB get cancelled. What are the remaining terms? Mu is equals to AO upon AI. So already I said very clearly in this diagram. So here it is A. From here to here, this is the real depth up to the O. Means AO is the real depth, AI is the apparent depth, OI is the apparent shift. That's right. So mu is the refractive index of the water. Is mu is equals to a refractive index of the medium. Which medium we are using there? Mu is equals to AO. A to O is nothing but real depth upon, what is the next one? A to I is nothing but apparent depth. So listen very carefully. So means by using the real depth and apparent depth concept also we can find the refractive index of the medium. So mu is the refractive index of the medium is equals to real depth upon apparent depth. But our concept is, what is that one? What is the vertical shift or apparent shift or raised position? Means what is this distance? That is we want. So we have find out that mu is equals to real depth upon apparent depth. So if apparent depth is transferred to the left hand side, mu into apparent depth simply is equals to real depth. Is it correct? So in this one, apparent depth is equals to mu transfer to the side. Real depth upon mu. So means to find the apparent depth in another mode is also you can find real depth upon mu. Means mu is the refractive index of the medium. So that's why real depth means the distance from A to O, and mu is the refractive index of the denser medium we are taken. That's why by substituting these values we can find where the image will be formed beneath the surface of the water or beneath the refracting surface. So real depth means what you are considering that AO. Is it correct or not? That's why this is, we should be write AO upon mu also we can write. Okay, which one? Apparent depth is equals to AO upon mu. Now, what is the apparent shift? Shift or vertical shift. So our topic is apparent shift or vertical shift. So already we defined that vertical shift is nothing but the distance, the vertical distance between initial position of the object to virtual image, means this one means OI. Is it correct or not? So OI is equals to, we can find this value, means AO minus AI is gives this value or not. So total A to O, this is the real depth, it is the apparent depth. So real depth minus apparent depth is gives this value or not. So that's why OI is equals to, simply first I write that. Okay. Vertical shift OI is equals to real depth. What is that one? AO minus apparent depth AI. That is one. So that's why simply OI is equals to AO minus AI. So already previously we find out that what is that one? Apparent depth is equals to AO upon mu. Is it correct or not? Okay, so that's why OI is equals to AO minus AO upon mu. Then OI is equals to, AO is the common factor, AO. Okay, so 1 minus 1 by u. We can find out that is nothing but OA is equals to real depth into 1 minus 1 by mu. So mu is nothing but here refractive index. So sin I by sin R is equals to mu. We can find out that mu is the refractive index. But here, okay, we know that according to the Snell's law, sin I by sin R is equals to mu. That is equals to mu2 upon mu1. Is it correct or not? Okay, so that's why here light is travel from where to where in the view of observer, radar to denser. But in the view of, okay, so based on the position of the object, light is travel from denser to radar. That's why the refractive index of the first medium with respect to the second medium, R is nothing but the refractive index of the air with respect to the water. So in the based on the position of the object, that's why you are considered that in this one. So 1 by mu is nothing but, okay, so we can write OI is equals to AO into 1 minus 1 by mu 1 upon mu2. Why mu1 upon mu2? Mu1 is the refractive index of the air and mu2 is the refractive index of the water. This is represented, what is that one? Light is travel. So mu of 1 2 is nothing but mu1 upon mu2. So mu of 2 1 is nothing but mu2 upon mu1. That is already we know that. So what is the meaning of this one? Light is travel from first medium to second medium is nothing but refractive index of the second medium with respect to the first one is mu2 upon mu1. Mu of 1, 2 is nothing but refractive index of the first medium with respect to the second, means light travel from second to first. That's mu1 upon mu2. Here, actually, observer is in the radar. In the view of observer, this will be possible. But actually, really, light is travel from where? From the denser medium to rarer. That's why light is travel from second medium to first medium, because of A is the first medium, what is the second medium. So that's why we should write mu1 upon mu2. That's why here mu1 upon mu2. It brings to the numerator side. What we can write? So OI is equals to AO into 1 minus mu2 upon mu1 is nothing but the light, okay, refractive index of the second medium with respect to the first medium, because of in the view of observer light travels from radar to denser is nothing but like this one. In the position of the object, light travels from denser to rarer. That's why this is the formula to find which one? Vertical shift. OI is nothing but vertical shift is equals to AO, means real depth, into 1 minus mu2 upon mu1 or mu of 2 1. It is also we can write V of S is equals to real depth into 1 minus mu of 1. So this is the formula to find which one? Vertical shift. So vertical shift is equals to real depth into 1 minus mu of 2 1 or 1 minus mu2 upon mu1. By using this formula, how much, what is the vertical shift? Means how much height the object position is rising when we can see from denser to rarer. About this one, in next video we discuss about one suitable example.